Hi, my name is Varun Chandelier. I'm a principal product manager in Azure Compute, and I'm very excited to talk to you about how can you scale your deployments in Azure Compute. We look at some of the best practices that you should be using to build your workloads, ranging from using the latest generation VMs to get the best price performance, leveraging VMSS instance mix and Azure Compute Fleet to find capacity using multiple SKUs, using VM applications as a way to deploy your applications on your VMs, and also we'll touch upon resiliency and security aspects, ranging from multi-AZ deployments, Azure Compute Gallery to deploy your images, hot patching for deploying security updates without any downtime, and Resiliency Hub. In Resiliency and Security section, we'll talk about the Azure Compute Gallery today. The concept there is that you should start safe and stay safe and resilient by design. By resilient by design, what we mean is there is aspects of resiliency that compute platform delivers, but there's also aspects of resiliency that you should be delivering as part of your workloads. Let's dive in. We'll talk about new VMs. We'll talk about direct virtualization, which is an update to our virtualization stack that we are bringing to market. We'll talk about instance mix and Azure Compute Fleet. We'll talk about schedule actions, which really help virtual desktop customers to make operations at scale. And we'll talk about large serverless containers, which help you to get more out of serverless containers. Let's dive in. We are enhancing our virtualization stack by introducing a new virtualization technology called direct virtualization. It helps you to access your devices like GPUs and NVMe disks directly without any performance degradation. It is efficient. It helps you to be isolated for better security. And it helps you to build applications within the VM, which you could not have done before. For example, if you want to run an AI workload, you need large data models, you need your agents or your inference workloads sitting closely with the model so that you have high throughput. With layered virtualization, you could have your large model sitting on the VM, and you can create child VMs which can access the model and network and the devices, including GPUs, directly to give you the best performance that you can expect to run your AI workloads. This feature is in preview. Use the link or the QR code to get access for this capability. Now let's dive into the VMs and silicon Azure has to offer. As you can see, we offer ARM-based VMs, AMD-based VMs, and Intel-based VMs. Our Cobalt 100 VMs offer best price performance that industry has to offer. If we compare Cobalt 100 to our previous generations, they offer 50% better CPU price performance. They offer 40% greater CPU performance, and you can exercise them with our V6 series. Similarly, on AMD, they offer 15% better price performance as compared to the previous generation and 20% improved CPU performance. Similarly, on Intel, with V6 VMs, we offer 10% better price performance and 20% better CPU performance. Our recommendation is always to use the latest generation VMs because they give you the best price performance that industry has to offer. The next question would be, how can I leverage these VMs and how can I minimize the operational overhead for my workload? This is where Virtual Machine Scale Set's instance mix comes into play. With VMSS instance mix, you can specify up to 5 VMs in a single deployment, and VMSS takes care of deploying these VMs looking at our real-time capacity. So you can scale out without any worries of capacity or challenges that come with it. So VMSS works with the capacity system to allocate the VMs for your workload. You can also mix spot and on-demand VMs together. VMSS will also help to deploy these VMs across availability zones, improving your resiliency footprint for your workloads. So, all in all, it simplifies the operational overhead that customers face when acquiring capacity. On the same lines, we've also made Azure Compute Fleet available in the market. Azure Compute Fleet simplifies large scale deployments up to 10,000 VMs in a single deployment using multiple SKUs and allocation strategies. You can provide up to 15 VMs in a deployment, and Azure will find the right capacity footprint to deploy them. In Azure Compute Fleet, you can also mix spot and on demand VMs together. Azure Compute Fleet will do the right allocation strategy using either price or capacity or a mix of those. Azure Compute Fleet also handles the evictions for spot VMs, simplifying your operational overhead significantly. We have few features in preview like multi-region fleet, in which you can deploy your Azure Compute Fleet in multiple regions to acquire capacity, and also attribute-based deployments, which help you to specify the shape of the compute rather than the SKUs itself. And Azure Compute Fleet, using those attributes, will pick the right SKU to deploy to fulfill your compute needs. These two features are in preview. Next, let's dive into schedule actions. Schedule actions enables you to update the power state of your VMs like start, stop, or hibernate at scale. Consider a scenario where you are deploying massive number of virtual desktops and you work at a bank. Your employees need to start at 9 a.m. So you want to start these VMs 9 a.m. in the morning, and 5 p.m. when the shift ends, you would want to shut these things down or hibernate them to save costs. Schedule events helps you to schedule these events, so you can put a schedule for starting your 5,000 VMs at 9 a.m. in the morning and then hibernate them, say, at 5 p.m. or 6 p.m. You can schedule these, and Azure will go ahead and make those operations possible. Let's quickly look at a demo for this.
Scheduled actions give the ability to perform power state operations on virtual machines at high scale. You can schedule stop, start, and hibernate operations on VMs immediately or at a time in the future on up to 5,000 VMs in a single operation. Scheduled actions sit above the compute APIs and handles both throttling and retries due to transient errors. For this demo, we are going to use scheduled actions to start and hibernate 200 VMs. The VMs will be started immediately and then hibernated in the future. Scheduled actions supports PowerShell, CLI, and REST API at this time. We are going to use the Azure portal to show the VMs and their power states. All 200 VMs are currently in the stopped, deallocated state. Next, we are going to use a REST API call to start the virtual machines immediately using scheduled actions. Batches of VMs can be submitted up to 100 at a time in a single API call. Resource IDs are used to identify what VMs to perform actions on. You can also specify the retry policy if you want scheduled actions to automatically retry transient errors. No time or date is specified in the request, which means the action is run immediately. After a minute, all 200 VMs now have the running power state. Next, we are going to hibernate all 200 VMs at a point in the future. We are now sending both batches of 100 VMs to hibernate at around 10 minutes from now. Skipping ahead, our target hibernation time has been reached and our VMs are now in the hibernated, deallocated state. In the future, we are looking to add more VM operations to scheduled actions, adding recurrence and further improving our scale and throughput.
As you saw in the demo, how easy was it for you to start and stop or hibernate your VMs at massive scale? In this example, we used lower scale because we were doing a lot of customization, but you could use up to 5,000 VMs to make these operations. Now, changing gears, let's talk about innovation in how we are helping containerized workloads to get more performance and scale. Till today, On Azure container instances, you could only deploy containers up to 4 vCPUs in size. We are launching large container sizes, which enable you to deploy containers up to 32 vCPUs in a deployment, massively helping you with better performance and also to do more with your containers. Now you can have workloads which need more memory capacity. You can simplify your scalability by packing more stuff into your container. Or if you have workloads which require massive CPU power, like data inferencing or big data processing, you can do that simply using ACI. ACI is integrated with Azure Kubernetes services, so you don't have to change your deployments on how you deploy your containers. You use AKS or Azure Kubernetes services to deploy ACI containers. Now you've deployed your containers, you've deployed your VMs. Now your VMs also need images and software on them. How do you deploy your images and software? Now, for VMs, we have this Azure Compute Gallery artifact management in which you can customize your image and you can save your images to deploy the VMs at massive scale. It simplifies management, it simplifies scale by replicating these images through different regions and replicating these images to give you higher throughput. You can share these images with different users, groups, regions, and even subscriptions and tenants. And because these images are backed by ZRS, which is zonally redundant service, it helps you to have better resiliency against zonal failures. Azure Compute Gallery helps you to deploy your application using a custom image at massive scale with high redundancy. Now you got your VM, you got your image, and maybe you didn't want to use a custom image, or maybe you didn't want to use a custom image, but you want to supplement that with more applications. This is one of the challenges that a lot of customers have talked to us about, and that is where Azure VM applications come into play, or VM apps. Using VM apps, you can publish apps, scripts, you can deploy up to 25 applications, 2 GB each per VM. It gives you high resiliency and reliability because Azure manages replication for these apps and you can update them seamlessly across different VMs. You can use VM apps and you can have 10 in region replicas to give you massive scale to reduce latency. It simplifies your application deployment, it helps you with resiliency, and it helps you with seamless updates. Whenever your app gets updated, VM apps can simply roll that out in a highly available manner across your VMs. Now let's get to another aspect. So for example, you deployed all these VMs and you need to customize these VMs before it can take a workload. Sometimes that can take a lot of time because you would have to download the bits, you have to do configuration, you might want to test the VM that it is ready for taking workloads or whatnot. That is precious time that is being wasted when you have load coming in to your workload. That is where standby pool comes into play. Standby pools enables you to create these VMs, customize them, and keep them in a standby pool available so you can put them in your scale sets when the workload demands more compute. It simplifies the deployment, it gives you very low latency to react to load, and it also reduces failure points. The VMs deployed in standby pools can live in two states. Either they could be running, giving very low latency to deploy these VMs to your scale sets, or to save costs, you can deallocate them. And when you are ready to get the load, you can simply just create the VM or you can start the VM and it will be transitioned into the scale set to take the load. As you can see, 50 running VMs can get started in less than 1 second. And 50 deallocated VMs take 60 seconds, but there is a price aspect that you can figure out what works best for you, how much latency is acceptable from a cost standpoint. But that is a great solution where you would have to do a lot of customization before you can take load on your VMs. We just didn't stop at VMs for standby pools. Container customers even push the boundary further when it comes to latency. So we introduced standby pool for Azure Container instances as well. The concept and how it works is similar to what it does in VMs, but in this case, you can create a standby pool for your container instances, even giving you even faster creation time and lower latency. Thank you for tuning into this presentation, learning about new innovation and products Azure Compute has to offer to help you build workloads, applications that can scale seamlessly, give you the best performance at the right price for you to be successful in Azure.